If you're trying to create a graph from a set of transformations, there is an order of operations you have to follow. It's very similar to normal orders of operations. You work from the inside out, but because of the way we evaluate functions, you have to be a little careful, especially when there's more than one thing going on inside the function. If you have say you have a reflection inside and a horizontal shift, you have to do the shift first, the horizontal shift first. Basically, the reflecting and the stretching and compressions, they come from the multiplication and can be done interchangeably in the middle, but you want to do horizontal shifts first, vertical shifts last, if you're starting with a graph and you're listing the formula of what you would need to do. Okay. Let me just show you a quick sketch that order really does matter. Sometimes it doesn't, but when you have combinations of multiplication and addition and so forth, it really does matter. So suppose I wanted to take f of x equals x squared and do two transformations. Shift the thing up 2 and reflect it across the x-axis. Well, look if I do that in different orders. If we go up 2 first and then reflect, well, the axis would act as a mirror and my reflection would look like this. The vertex would be down here at -2. It would reflect from 2 to -2. But if I were to reflect the graph first and then move it up 2, it would look more like this graph here where the vertex is up at 2. Okay. So the order does make a difference. You want to do horizontal shifts first, then reflections and stretches and shrinks, and then vertical shifts last. For the most part, work your way from the inside out, but on the inside, make sure you do the horizontal shifts first if you have more than one occurring. Okay, so now we're going to combine a couple of things here. Okay, so we're going to graph y equals x squared, or f of x equals x squared, and then do this transformation, x minus 2 squared plus 3. So the original graph goes through 0, 0, 1, 1, 2, 4, -1, 1, -2, 4, and we get the parabola shape. This graph, first we have an x minus 2 inside, so we would have to shift horizontally. There's a minus, so it would go in the positive direction to the right 2. And then a plus 3 on the outside would go up 2. Okay. That's technically the order you should follow, but here it doesn't matter since you're just doing the two shifts. If you go, sorry, this would be up 3. If you go up 3 and then to the right 2, you'd be in the same spot. So I'm going to take this graph and take each point and just kind of count over. I'm going to go to the right 2 and up 3. The new graph would be up here. I'm just going to do those 3 points. So there's x minus 2 squared plus 3. For parabolas, we call that point the vertex, the maximum or the minimum point. It's originally at 0, 0. In this form, we can see it's going to move to 2, 3 because it's going to go forward 2 and up 3. Okay, let's do one more. We're going to do -1/2 x plus 1 squared minus 3. Okay, so this is actually called the vertex form of a parabola by most books, because you can see that the vertex is going to go from 0, 0 to hk when the thing moves in the opposite direction for the horizontal shift, and then up k or down k if k is negative. And then it's got a stretch and a reflection, in this case out there by a. So let me do it one transformation at a time first. On the inside we got a plus 1. So that's going to take my original graph, and I'm just going to use the 3 points, 0, 0, 1, 1, and -1, 1. So there's x squared. The plus 1 is going to move that thing to the left 1. And then I'm going to do the -1/2 together. That would take my y values times a -1/2. So 0 and -1/2. These 2 points had y values of 1. They'll go to -1/2, and we'll get one that is both reflected and vertically shrunk by a half. And then finally move it down 3. One thing you might notice when I'm drawing these, once I find the vertex, I can just move out in each direction and go down a half. I'm using the fact that it has the same shape around the vertex as it does around the origin in the original graph. But anyway, there's the final graph, f of x, where we have moved it to the left 1, reflected it upside down across the x-axis, vertically compressed it by a half, or vertically shrunk it by a half, and then moved it down 3. Okay, and then the last two questions here, these are questions, the types of questions that teachers like to ask, because you're not just going to punch this in a calculator and see the graph. You actually have to know your transformation rules to do this. So on example 7, you're not going to draw the graph, you're just going to list the transformations. So starting with that function, what are the transformations you would do to x squared to create this graph if you go in the correct order? Okay, so if we want to list the transformations, first on the inside we've got an x plus 1. Sorry, let me switch screens here. On the inside we've got an x plus 1, so that would be a horizontal shift. The plus, we'll move it to the left 1. And then on the outside we are multiplying by 2, so that's a vertical stretch, since 2 is bigger than 1, by 2. And then finally, here's what would make it a challenge to graph on your calculator. You'd have to change the window because this thing is shifted. It's a vertical shift, but shifted down 50. Okay, so we got a shift to the left 1, vertical stretch by 2, down 50 in that order. Okay, and then our last question, we're going to write a formula for a graph that starts with absolute value of x, and then in this order moves it to the left 1, vertically stretched by 2, and down 4. Okay, so this time we want to write the formula. I'm going to do it one step at a time here. Back to my iPad screen. So we're going to take absolute value of x and we're going to move it to the left 1. That would give us on the inside an x plus 1 to go to the left 1. And then a vertical stretch by 2, we would multiply that by 2. And then finally down 4. And we would get our formula. 2 times the absolute value of x plus 1 minus 4.